Oh, hey, I didn't see you there. I didn't know you were coming to my house today. So I just wanted to put my beautiful face in front of you for a little bit to clear up any confusion on what we're going to be going over for the next week or so, as well as to give you guys a little bit of a demonstration of what we would be doing in class, but now we're not going to be able to, at least in person. So hopefully with this interaction, this will clear up a little bit of confusion on what we're going to be doing over the next week or so. So as hopefully you figured out, the main question that we're going to be attempting to figure out is the question of why do some things stick together and other things don't. For example, when you do the laundry, if you've ever done the laundry in your life, and you notice that some clothes come out and like maybe there's a sock stuck to a shirt or something along those lines. If you've never seen that, maybe do the laundry for once and see if it actually happens or not. We're going to be talking about why that might happen. Why do sometimes the clothes stick together and other times they don't stick together? So we're going to be taking our chemistry knowledge that we got in third quarter, that I'm sure you all remember perfectly, and we're going to be applying it to actual situations for this quarter. So you guys have all logged on to the learn.concord.org website where you've created usernames, you've gone through a pretest where you probably knew absolutely nothing about what we're going to be talking about. And that's okay. Remember, it's just designed to figure out what you know or don't know. And it's going to help me kind of figure out how many videos I need to make to clear up any confusion, as well as any supplemental stuff that we need to go over to make sure that as we progress through this unit of trying to figure out why some things stick together and other things don't, to be able to identify where those gaps are at. So what you've done is you've taken the pretest. What I need you to do for right now is I need you to go back to learn.concord.org, log back in, and what you should now have access to is the next investigation, Unit 1, Investigation 1. It's going to go through much slower as we kind of piecemeal this knowledge stuff together. So go ahead, take a minute, log on to learn.concord.org, click on Unit 1, Investigation 1, and hit Begin Activity. I will pause so that you guys can go ahead and do that. I'm just kidding. I'm actually going to pause the video so you guys can do that because I can't hold it for that long. So I will wait. Pause now. Great. So you've gotten on to the first page where you saw two pictures, right? A picture of a cat with some styrofoam peanuts attached to it and a picture of a kid with his hair sticking straight up. So there's two questions on there that hopefully you answered or thought about, and that is, why do some things stick together? Or why does the hair pull up? Why is the styrofoam attached to the cat? What do you think is going on in those scenarios? So depending on what you thought, some of you maybe have put something like static, or magnetism, or even magic. I don't know what you guys put. There's no wrong answers for right now. So whatever you put, just make sure it's in pretty good detail for both the guess and whatever questions you might still have on why some things stick together. So as you guys know, science is all about making observations, using those observations to make predictions of what might happen, and doing some tests to figure out, do those predictions make sense? So what you've done is you've answered your initial thoughts on why you think things stick together, or why hair sticks up, why peanuts stick to cats, whatever it might be. And the next thing that we're going to do is we're going to start putting those guesses into practice to see, does that match what actually happens? So if you click onto the second page on the learn.concord.org website, it's going to take you to basically a Van de Graaff generator with some questions that will eventually be happening. Before you answer any of those questions though, I wanted to walk you through what this is. This is a Van de Graaff generator. We would be doing stuff in class, but obviously we can't be doing it in class. So I'm going to show you some of what it can do for right now. And unfortunately, you guys won't be able to be shocked by it yet, but hopefully we'll be able to come back to school eventually and you guys can go through it for right there. So I'm going to turn this thing on. I'm going to show you the basics of how it works, and then that will help you as we go throughout the rest of this investigation. So what the Van de Graaff generator is it's got a belt that is rotating very, very fast. and there's this giant bell right here. And what is being produced essentially is a shock. So I have this metal on metal. So when you go, it produces a shock, right? Now it's a pretty humid day, so it's not as powerful, but it produces a bit of a shock. It also will be able to attract certain things. For example, if I take a piece of paper, you will see that it will be attracted to the Van de Graaff generator. As another example, with the hair thing, I have my lovely assistant who's going to show you if you were to bring your hair next to the Van de Graaff generator, what would happen? Hi. So you can put your face near that thing. So you can see his unkept hair, right? It's completely sticking right towards the Van de Graaff generator. You can move your head all around. Do it again if you want. It's beautiful. It's lovely. So what I want you guys to do is think about what you're seeing when you see that lovely hair being attracted to the Van de Graaff generator. Okay? So we're going to be doing more with this later on. So you can go. Yeah. So what I want you to think about is, why did that happen? That's going to be some of the predictions you're going to make. Why did the hair get attracted to the Van de Graaff generator? Again, I know you guys are thinking, well, static electricity, but we need to figure out what is static. What does that mean in more detail? So what I want you guys to do for right now, okay, is on page 2, there's a picture of pie pans on the Van de Graaff generator. I want you to make your prediction of what you think will happen to those pie pans when the Van de Graaff generator is turned on, and type those predictions in. I do not want you to go ahead for right now, just make your predictions. So pause, make your predictions. All right, now that you've typed in your predictions, if you go to the next page, there's going to be pictures of the Van de Graaff generator with a link to a video that's going to show what actually happened when pie pans were on the Van de Graaff generator. So after you made your prediction, watch that video, see what happened with the pie plates, okay? And then in the model, I want you to draw why you think it happened. Remember, in your drawing, it should be clear what the observations were, and there should be some sort of prediction as to why you think whatever happened happened. So I should see either pictures or words or arrows or something in your drawing that is some sort of prediction as to why you think what happened with the pie plates, why you think that happened. For right now, only make those drawings. I don't care how wrong it is, just try to make it as detailed as possible for what you think was going on. And that's all we're going to do for right now. Later on, we're going to come back and talk about, one, how to make a model better, and eventually we'll get into why what you saw happen actually happened, again, as we investigate our main question on why do some things stick together and other things don't. So I hope this helped you guys a little bit. If you have any further questions, send me an email, and I'll be happy to get back in touch with you. Again, miss you guys. Hope you guys are enjoying your little mini vacation, and I'll talk to you guys soon. Bye.